Earlier today, on September 13th of 2025 at 2:37 p.m. local time, a major earthquake struck once again just offshore of Russia's Kamchatka peninsula. Registering in as a magnitude 7.4, it soon shook the ground rapidly back and forth across a land area the size of Kansas for approximately 29 seconds. During this time span, there almost certainly was damage caused to a number of buildings, but if early reports are anything to go off of, the damage was only minimal to modest. No injuries or deaths were reported, but because of the earthquake's origin on a megathrust segment, it triggered a tsunami warning. This tsunami warning detailed the potential for damaging waves of 1 meter or 3.3 feet or more across a 1,000 kilometer or 621 mile radius. Yet, as the time passed, no tsunami waves arrived, so the warning was rescinded. And I think I know why no tsunami was triggered. Simply put, while yes, today's earthquake was a lesser magnitude megathrust earthquake, unlike July 30th's larger 8.8 earthquake, it appears that no measurable displacement of the ground reached the surface as you can see in this chart. Also, this earthquake had an epicenter of 4.5 kilometers deeper than its larger July counterpart, striking at 39.5 kilometers or 24.5 miles depth. Today's earthquake just so happened to represent the largest aftershock to have occurred so far following the earlier magnitude 8.8 earthquake. And surprisingly, it wasn't all that unexpected in the long term due to statistical averages from prior similar magnitude world earthquakes. You see, generally speaking, the average largest aftershock following a main shock earthquake is 1.2 magnitudes lower than the main shock. That gives us a figure of a 7.6. Also, if we look at the U.S. Geological Survey made aftershock forecast that was made on the same week the magnitude 8.8 earthquake struck, it suggested that around 3 magnitude 7 earthquake aftershocks would be expected within a year, along with 34,000 magnitude 3 or larger aftershocks. I now want to note something peculiar and interesting regarding today's earthquake. For reference, here are the U.S. Geological Survey made models which show how much specific parts of the fault plane in question slipped during the July 30th, 2025 earthquake. Note how there are gaps where very minimal if any motion occurred. Well, today's earthquake struck at the edge of one of these gaps, causing the fault to slip by as much as 1.1 meters or 3.6 feet. If we assume that most additional magnitude 6 and 7 aftershocks that are probably going to occur will happen in these gaps, it suggests some potential for those to occur in these highlighted regions. Some of these could be equally deep, with the potential for shallower aftershocks that would be more likely to cause higher damage than today's earthquake are possible. However, those statements are largely opinion-based and speculative. Going back to the damage which occurred, it is quite likely that a few landslides occurred, especially on steep cliff faces near the coastline in this particular peninsula. Some liquefaction is also modeled to have occurred in many uninhabited regions, but also farmland and some more populated spots. As for volcanoes, unlike July's magnitude 8.8 earthquake, there are currently no indications that the latest quake triggered new activity at any regional volcanoes. While yes, 17 regional volcanoes did experience MMI5 or greater intensity shaking, indicating a theoretical potential for something to happen if a volcano was already primed to erupt, no changes have yet been noted. The slip which occurred in the magnitude 7.4 earthquake could best be thought of as rupturing not along a straight line but a rectangle, in this case measuring 70 kilometers long and 35 kilometers wide. An increase in lesser magnitude aftershocks should temporarily happen following today's event, but will quickly decrease in number as time progresses. Stay tuned for more updates. As a final note, I would like to thank this channel's supporters on Patreon and our YouTube members for supporting my work.